Hi everyone, this is Gryshchenko and today we're going to speak about PaLM-E and Embodied Multimodal language model. Machine learning has made enormous strides in recent years, from models that can understand jokes or respond to visual queries in a number of languages that can create images from text to descriptions. The availability of enormous datasets that has increased, and new developments have made it feasible to train models on these datasets, making these environments conceivable. Due to paucity of datasets on a scale equivalent to big text, corpora, or picture datasets, scaling of robotics models has seen some progress, but is lagging behind other fields. An embodied language model and also a visual language generalist. On the one hand, PaLM-E has created as a model for robotics in order to address a range of problems on various robots types and for various modalities, like pictures, robot states, and neutral scenes representations, among other things. In addition, PaLM-E is generally a functional vision and language model. It is adept at language-based activities like reciting poetry, resolving mathematical problems, and creating code. It can also do visual tasks like describing visuals, identifying objects, and categorizing situations. PaLM-E combines one of the most vision models, V22P, with our most current big language model, PaLM. The biggest implementation of this method based on PaLM 540B is known as PaLM-E 562B, and without task-specific fine-tuning and while maintaining roughly the same general language performance as PaLM 540B, sets a new state of the art on the visual language OKVQA benchmark. So right now we're going to speak about how does it work. How does the PaLM-E work? A pre-trained language model is a fed data to make PaLM-E function technically. This is accomplished by processing sensor input such a picture into a representation using a method similar to how words in a language model are handled. Language models really rely on a method for mathematically representing text in a form that neural networks can understand. To do this, the text is first divided into tokens that represent subwords and are individually linked in a high-dimensional vector of integers called token embedding. The next most probable word token may then be predicted, but the language model uses mathematical operations, such matrix multiplications, on the resultant sequence of vectors. The language model can repeatedly create texts that can longer and longer be feeding the newly anticipated words back to the input. So as you can see the photo here. So the goal of PaLM-E is to develop encoders that can transform a range of inputs into the same spatial domain as an embedding of natural word tokens. These continuous inputs are translated into something that resembles words. The word, an image embedding may now be supplied into the language model because they have the same dimensionality. Next topic is transferring knowledge from large-scale training to robots. So by bringing robots tasks and and vision language tasks together through the single representation, taking pictures and text as an input and producing text. PaLM-E offers a novel paradigm for training generalist model. One important outcome is that PaLM-E achieves notable positive information transfer between the language and visual domains, enhancing the efficiency of robot learning. In comparison to training individual models on individual tasks, the results demonstrate that PaLM-E can address a large number of robots' vision and language problems simultaneously with the performance deterioration. Furthermore, the performance of robot tasks is actually significantly enhanced by the visual language data. PaLM-E may learn robotics tasks more effectively, because to this transfer in terms of the quantity of instances needed to be completed a job. So as a result, we can test PaLM-E on a general vision language tasks, including visual questions, answering, picture captioning, and general language tasks in 3 robot settings, 2 of which contain actual robots. We combine PaLM-E with the low-level language to action policy to convert text into low-level robot action when PaLM-E is required to make choice on a robot. In the first illustration below, a human requests that a moving robot brings them a bag of chips. PaLM-E creates a PaLM to locate open the drawer in order to accomplish the mission, and when it actually carries out the work, it adapts to change the environment by updating the plan. In the second illustration, a green block is required of the robot. PaLM-E still develops a step-by-step plan by generalize beyond the training data of the robot, even if it has not encountered the block. The same PaLM-E model is used to do extremely long horizon practice tasks, including sort the blocks by color into corners, for example. On a different kind of robot in the second setting below, it performs a series of shorter text represented actions after taking a straight look at the visuals, such as push the blue cube to the bottom right corner, push the blue triangle there too. Long horizon jobs that even our own most recent models were out of the question of autonomous accomplishment. We also show that we can generalize the novel task that we are not encountered during training, such moving red blocks to the coffee cup. The third robot environment draws in and motion planning, which investigates combinatorially difficult planning problems that present the robot with a feasible number of potential action sequences. We demonstrate that PaLM-E is not only capable of solving these tasks with a little amount of training data from an expert TMP planner, but it also makes use of visual and linguistic knowledge transfer to do so more efficiently. So in the conclusion, PaLM-E pushes the limit of how generally capable models may be taught to take on tasks related to vision, language, and robotics at the same time, and be able to apply for they learn from those tasks to the robot domain. In-depth research is done on a number of other subjects in the study, including how to use PaLM-E with the neutral scenes representations and how much less catastrophic language forgetting PaLM-E experience as a model scale increases. PaLM-E not only offers a way to create more proficient robots that can take advantage of various data sources, but it also be a major enabler for other more general users of multimodal learning, and such as a capacity to combine activities that have previously appeared to be unrelated. So it was Gryshchenko David. This topic was about the PaLM-E. Thank you for listening. Thank you for your attention.